Okay, we will go through the some important points in the class 11 physics chapter gravitation. Okay, these are some scientist names. See here this Kepler's law of gravitational motion. First lies law of orbits. Okay, it says the earth is revolving around the sun with sun in the elliptical orbit with the sun as one of its foci. Okay, this elliptical orbit have two foci. One of them is occupied by the sun. Okay, sun is one of the foci. Okay, it is in elliptical orbit. Earth around the sun in an elliptical orbit. There are 2 points, perihelion and aphelion. One is near to the sun. So this point is near to the sun, P perihelion. This is away from the sun. See, if you take any point on this orbit, let us say this point T, the distance from F1 plus distance from the F2 is constant. You can take that point here also. Distance from this foci and this foci adding it will be constant. Okay, that is important here. This is semi-major axis. This is a constant. So that is given here. Clearly for any point T on the ellipse, the sum of the distance from this is constant. Okay, that is important. Semi-major axis. Law of areas. Second law of Kepler. This it says that equal areas are covered in the equal interval of time. Okay, if the time from year to year, let us say 1 second means, and from year to year also 1 second, if these two areas are same. Okay, same areas are covered in the same time. Law of area, second law. The law of periods, that is the third law. The square of the time period for the revolution of the planet is proportional to the cube of the semi-major axis. Okay, square of the time period is proportional to the cube of the semi-major axis. That is third law. What is central force? Okay, central such that the force on the planet is along the vector joining the sun and the planet. Okay, that is the central force. The third law is based on the linear angular momentum conservation. Okay, third law. Sorry, not this law. Okay, you can go through this. Is conservation of the angular momentum. Gravitation is the central force. Is hence the law of areas follows. Okay, law of areas. Law of areas. So this is based on the law of areas. That is closer to the sun, the speed will be more when they are away from the sun. This is the moon orbit radius. This is the gravitational force. Product of their masses divided by the square of the distance between them. This G is the gravitational constant. Negative sign is attract. So here this in this problem you see the direction of the force using the unit vectors, that is important. On these unit vectors, which direction this force acts in this equilateral triangle. Okay, for this sum. So you have to understand this unit vector. So the net force on the center of the equilateral triangle is 0 because of this symmetry. Okay, the resultant gravitational force center is 0. Uniform density is important. How to find the gravitational constant? This experiment is used to find the gravitational constant. This is the value of the gravitational constant G. So what is the gravity at a point outside the earth and inside the earth? So those two are different. That is, earth surface outside the earth and the inside the earth, they are different. Force on a point outside and inside. See here, this acceleration due to gravity is independent of the mass of the object. Okay, this is important from this formula. It depends on the mass of the earth and the radius of the earth. It is independent of the m means mass of the object. That is 9.8 meters per second is that approximately g, independent of the mass of the object. Here h is the height above the earth's surface. This is the difference between the height and the gravity. Okay, g. More g when the height is more. So when d is the below the surface, this is the relation. This is inside the earth. This is important. Earth's gravity is that it is maximum on its surface. Okay, this is important. Gravity is maximum on the earth's surface, decreasing whether you go up or down. Okay, if you go inside the earth also it will be decreasing, go above the earth also it is decreasing. It is maximum at the surface of the earth. This is a conservative force, gravity. They have to compute the work done. Gravitational potential energy from one point to other. Okay, moving object from one point to the other. See, this gravitational potential energy is different from the gravitational potential. Gravitational potential energy is between these two masses. Okay, whereas gravitational potential is with respect to one mass. Okay, potential energy, potential are different. Okay, in this question. Potential is work done per unit mass. Okay, per unit mass. Potential energy is between two masses. So here they are asking what is the potential due to the masses. You have to add up potential due to this mass. Okay, that is why you get 4 here. So gravitational potential, these two are different. That is why I written that. So this is the escape velocity of the earth. Okay, if you want some object to escape from the earth, you have to launch with this speed, more than this speed. Okay, rockets use this formula to move out of the Earth's gravity, escape velocity. Okay, you can go through it. Earth satellites, elliptical orbit. The centripetal force is directed toward the center. This is the period of that orbital satellite. Period is inversely proportional to the gravity. Okay. More gravity means the time will be less for the orbital to move to complete one orbit. More gravity means in a less time. Less gravity will take more time. Period is inversely proportional to the gravity. Okay. How the energy varies in the orbiting satellite. Okay, kinetic energy and potential energy, how it varies from point to point on the orbit. Okay, you can go through this summary. Okay.